This next video tutorial is related to the lesson on literal equations and formulas, and to help us a little more with that understanding, we have some examples we're going to take a look at. The first example says, solve the equation 7 equals 3a subtract 4b for a. What are the values of a when b is equal to a negative 3, 0, and a positive 3? So let's take a look at that. If you look at the equation 7 equals 3a subtract 4b, you'll notice that there are two variables in that equation. That's what we call a literal equation. And so the instructions ask us to solve for a. So I'm going to go ahead and write the original equation, 7 is equal to 3a subtract 4b. And remember, we're solving for a here, so I'm just going to make a little note here. Solve for a. That's what we're looking for, is the value for a. So to do that, we have to isolate the a variable. Everything else on that side of the equation has to go. Now if you look at the equation, we have 7 equals 3a subtract 4b. In order to begin the process of isolating the variable a, we need to eliminate the subtract 4b. Well, the opposite of subtract is add. So we're going to go ahead and begin by adding 4b to the right side of the equation. The addition property of equality says that in order to maintain the balance, we have to add 4b's to the left side of the equation. Now 7 and 4b are not like terms, and so we will not combine them as a single term. Instead, we'll just write that we have 4b's and we have a 7. So we can consider that those two terms as part of a group. And then on the other side, we have our 3a. The subtract 4b and the add 4b, a negative 4b and a positive 4b are additive inverses of one another, and so they make 0. Now that we have our updated equation, we can look at how we undo multiply by 3. Well, the opposite of multiplying by 3 is dividing by 3. So if we use the division property of equality, if we divide the right side by 3, we're going to divide everything on the left side by 3. 3 divided by 3 is 1, and so sure enough, we've isolated the variable. We have a is equal to, and the numerator is 4b add 7, and the denominator is 3. So 4b's added to 7, all divided by 3, is equal to a. Now we have to determine what is the value of a given a specific b values. So let's just come over here and say b is equal to negative 3. What happens when b is equal to negative 3? Well, then that means that a would be equal to 4 negative 3's, or 4 times negative 3 added to 7, all divided by 3. 4 multiplied by negative 3 is a negative 12. We would then take negative 12 added to 7 and divide by 3. A negative 12 added to 7 is a negative 5. So that's negative 5 divided by 3. And another way of writing that is negative 5/3. So when b equals negative 3, a is a negative 5/3. Well, what happens when b is equal to 0? That means we have a is equal to 4 zeros. So 4 times 0 adds 7, all divided by 3. 4 times 0 is 0, and so we're left with 7/3. Or well, we could write that as a that improper fraction as a mixed number. 7 divided by 3, 3 goes into 7 twice, with 1 left over, so we could write that as 2 1/3. And finally, what happens if b is equal to a positive 3? We have a is equal to 4 of the number 3, so 4 times 3 added to 7, all divided by 3. Well, 4 times 3 is 12, and then we add that 7 to that, and we divide everything by 3. 12 add 7 is 19. So we have 19/3. That's an improper fraction. So another way to write our solution is as a mixed number. 3 will go into 19 6 times with 1 left over. So we could write that as 6 with 1 left over, so we have 6 1/3. Let's take a look at the next example. It says solve the equation e subtract 5f equals 15 for f. So again, we're solving for f, so that's the variable that we're going to isolate in this literal equation. Okay, so I'm going to go ahead and start by writing the equation e subtract 5f is equal to 15. Since I'm solving for f, that's what I want to isolate. So I'm going to focus on e. And I'm going to start by subtracting e from the left side. Using the subtract property of equality, I'm going to subtract e from the right side as well. Okay. E subtract e means we don't have any, the e is gone, so now we have negative 5f is equal to, and negative e add 15. Okay, we still haven't isolated the f completely yet, so to isolate the f we have to undo multiply by a negative 5. We do that by doing the opposite of multiplication, which is division. So we're going to divide everything on the left side by negative 5, which means we need to divide everything on the right side by negative 5. Negative 5 divided by negative 5 is 1, and so we have 1 multiplied by f, which means that f is equal to a negative e added to 15, all divided by a negative 5. Okay, in this example we have a formula. It says, in this example, the area of a triangle formula is A equals 1/2 BH. A is our area, B is our base, H is our height. So in order to calculate the area, we need to take the base, multiply it by the height, and then multiply that product by 1/2. Then it asks, what is the base of a triangle that has an area of 30 inches squared and a height of 5 inches squared? Okay, well let's start by writing down the area formula for a triangle. So we have area is equal to 1/2 multiplied by the base multiplied by the height. Now, in order to find the base, we need to solve for b. So I'm going to write here a little note to ourselves. Solve for b. That's what we're isolating. That's what we're trying to find. In order to do that, the 1/2 and the h, we've got to move those out of the way. Alright, so in order to solve for b, we have to undo multiply by h. We undo multiplication with division, and the division property of equality tells us that we divide both sides by the same amount in order to maintain the equality or balance of the equation. So here we have a divided by h on the left, and 1/2 multiplied by b multiplied by h, all divided by h. Well, h divided by h is 1, and so we're left with an equation that looks like this. A divided by h is equal to 1/2 multiplied by b. Now the next thing we need to do is figure out what to do with this 1/2. Well, as it just so happens, 1/2 has a multiplicative inverse. The multiplicative inverse of 1/2 is 2. So if we multiply 1/2 by 2, we should get 1 as our product. So let's go ahead and multiply the right side by 2. But that means, using the multiplication property of equality, that we need to multiply the other side by 2 in order to maintain balance and equality. So that means, as we look at that, 2 multiplied by a is 2a, all divided by h, is equal to, I'm going to use the commutative property of multiplication to move this around a little bit. We have 1/2 multiplied by 2 multiplied by b. Well, the nice thing about the 1/2 multiplied by 2, because they're multiplicative inverses of one another, 1/2 multiplied by 2 makes 1. So now our equation is 2 multiplied by a, all divided by h, is equal to b. Now remember, we're trying to find the base of the triangle if we know the area and we know the height. So let's see if we can figure that out. The base is equal to 2 times the area, and in this case the area is 30 inches squared, all divided by the height, and we know the height to be 5 inches. 30 divided by 5 is 6, so we can write that as a 6. Inches squared divided by inches becomes just inches. And so we have B is equal to 2 times 6 is 12 times inches, so we have the base of that triangle is 12 inches. Now just for fun we can do a quick check because we know the area formula. The area was given as 30 inches, so I'm just going to write here, let's just do a quick check just to verify. So the area of the given area was 30 inches squared. And then we have 1/2 times the base we calculated as 12 inches. The height was given as 5 inches. Now let's see where that takes us. Okay, so we have 30 inches squared on the left side of the equation. We have 1/2 times 12. Well, we know that 1/2, or that half of 12 is 6. So we have 6 inches multiplied by 5 inches. And when we do that calculation, we find that we get 30 inches squared on both sides. So the solution checks. So B is equal to 12 inches.